This video is about similar shapes. This means if we have two shapes that are similar, that the angles in each of the two shapes are the same, and also their side lengths are in proportion. In this example, we have two triangles. One's a bigger copy of the other one. This angle here is the same as this one. They tell us that here. And also they both have right angles, so clearly this angle at the top must also be the same. So the two triangles are similar. We've got to work out the length x, which is the length of the line PR. Two ways we can do this. I can compare the height of this one with the height of this one, and then the base of each one. I'll do that first. So I'm going to say that x over 9 must be the same as 10 over 15. Okay, and if I then multiply both sides by 9, it would give me that x would equal 10 over 15 times 9, okay, which is 90 over 15, which is 6 centimeters. So it's a really easy question, that one. There's another way we could do it. I'll just show you this as well. So instead of starting by comparing the x with the 9 over there, I could compare the x with the 10. In other words, its height with its own base. So I would have x over 10, and I would say that that is the same as 9 over 15, doing the same on the other triangle. Work that out, you get exactly the same answer, okay, because you'd end up this time multiplying 9 over 15 by 10, which of course would give you 6 as well. Okay, so they're both leading to the same answer for that one. Okay, the next question is a little bit more complicated, because this time the two triangles are within each other. We know they're similar. There's a big clue here, because these two edges, or sides rather, are parallel to each other. We're given some information. I'm going to put it on the diagram. We're told that this is 8.1 here, and we're told that this length up here is 5.4. Okay, now just using those two facts alone, we can immediately see the scale factor between the two. And that's really useful, actually. So to get from the small one to the large one, I'm multiplying by 8.1 over 5.4. Okay, and if you work that out on the calculator or without the calculator, it's 3 over 2. So basically it means that all the lengths on this triangle, the bigger one, the outside one, are 1.5 times the size of the ones on the small triangle. And that's going to be really useful now. So I'm going to put here that EC is 8.1, DC is 5.4, and DB is 2.6, which is this one here. Okay. So I've got to work out AE. I'm just going to call that X. So using this fact here, I can simply say that X is going to be simply 2.6 times the scale factor between the two, which is 3 over 2. Okay, and that simply comes to 3.9 centimeters. So that's really easy. And the next question is asking me to use the fact that AC is 6.15. I'll put that on the diagram, 6.15, to work out what the length of AB is. Now AB is this bit here, which I'll call Y, okay? Now, there's several ways you could do this, but what I'm going to do, I think, is work out the length of BC, because I know that BC is 2/3 of AC, okay? So I'm going to put that BC is the length of AC, 6.15, And because I'm going from the large one to the small one, the scale factor is 2/3, you see. Well, 2/3 of 6.15 on the calculator or without is 4.1. Okay, and so if this is 4.1 here, that's BC, then the total length is 6.15, so I can work out y. So in other words, AB. So the length AB is going to be 6.15 minus 4.1, and that leaves you with 2.05 centimeters. Okay, so it's important to show you're working out, and as I said, there are several ways that can be done in a lot of these kinds of problems. Okay, in this one, I'm going to do the same kind of thing. I've got one triangle within another one. I've been given some lengths, but there's also some questions here about angles. So we'll just deal with the angles first. So if I put that here for part A, so for part 1, okay, the angles, it's asking us to calculate the size of DEB, which is this angle in here. Now what I'm going to do is I'm going to say first of all that AEB, okay, angle AEB is the same as this one because it's a corresponding angle, and it wants me to explain my answer. So I'm going to say here that I'll do part 1 and 2 at the same time, really, because I'm going to explain the answer as I go. So I can say that angle BEA, angle BEA is equal to angle CDA, which is equal to 105, okay, and that's corresponding angles. That's the reason or the explanation, okay. And the next thing I need to do is I need to take 105 away from 180 to get the angle BED or DEB, which is what I want. Angle DEB equals 180 minus 105, which is equal to 75 degrees. Okay, and it's quite easy to see that that's the case if I put 105 in there, okay, because that's the same as that, then this must be 75 in here. But you need to explain, which is what I'm doing over here. So my reason for saying that is that angles on a straight line, okay, angles on straight line. Okay, now for the next part, calculate the size of AE. So AE is this length here, which I'll call X. Okay, now what I can do here is I can say that I have two triangles similar, and this has a side there of 3. So this is the triangle that I've taken out, ABE, okay. And if I drew next to it the original triangle, the larger one if you like, that has a side of about, well, it's longer by a certain amount, and instead of that being 3 up there, it's 5, so I'll make it look a bit like 5. It's about there, and this one here is there. So this is the original larger outside triangle, if you like, with C at the top, and that's C, and this is D down here. Okay, so what I'm saying now is that that's 5 and that's 3. So I can see that the area scale factor is, the linear scale factor is 5/3. Okay, so anything on this triangle is 5/3 bigger than this one. Okay, so what I can say is that the total length of AE, which I've called X, so I could say that X, okay, which is AE, over the total length of AD, which is X plus 4, okay, that must be the same as 3/5. Okay, this is one way I can do this problem. If I cross multiply, okay, so from this, okay, I can cross multiply. In other words, 5x is equal to 3 lots of x plus 4. Okay, if I process that, I get 5x equals 3x plus 12. Okay, if I take away from that the 3x from both sides, I get 2x equals 12, and then x must therefore equal 6. And that is one way of answering that question, and it's 6 centimeters. Okay, so basically this is 6, that's 4, making a length across the bottom of 10. Okay, and there's other ways you can see that that must be true. Okay, but that's all my working out. Next question. Okay, now these two are drawn to look exactly the same. They're the same scale, the same size, exactly the same shape, but of course one is bigger than the other because of the numbers shown in the diagram. And what is the scale factor? Well, we've got to work out the length of DF, and it's quite easy to spot straight away that you've got two corresponding sides, and the scale factor between those two is exactly 1.5 or 3/2. So if I'm going from this one to this one, okay, 12.6 over 8.4 is exactly 3/2. Okay, 3/2. So basically this triangle on the right is 1.5 times bigger than the one on the left. Okay, on the one on the left is 2/3 the size of the one on the right. So all I need to do is to work out DF. I just need to multiply 6.4 by 1.5 or 3/2. 6.4 times 3/2. Okay, and that's going to give me 9.6. So that's the length of DF, 9.6. I'll put it there as well. And finally, we've got to work out the length of CB. I'll do that just here. Well, CB is going to be 2/3 of FE. So CB is going to be 15 times 2/3. Okay, which is simply 10. So once you found the scale factor, these sorts of questions are really quite simple. So that's 10 centimeters along there. And you can check lots of different ways to see that that fits with everything that you have there. Okay, so next question to look at. Okay, now this is about volume and area as well as lengths. So this gets a bit more complicated. These are solid shapes. They look like two chess pieces, and the ratio of the surface areas are 3:4. That means if you were going to paint that 3D shape, you would need 4/3 the amount of paint to do B than A. So suppose you needed 3 brushfuls of paint to cover shape A, you'd need 4 brushfuls of paint to cover shape B. okay, because that's like the surface area comparison. Okay, but the question is, the volume of shape B is 10. Work out the volume of shape A. Now, of course, the big mistake is just to say, well, if they're in the ratio 3 to 4, then it must be 7.5. Well, that's wrong, okay, because it doesn't work like that. That's for area, not for volume. And this is what we have to do. Draw up a little table. Length, area, volume. Okay. Now, the area scale factor, okay, is 4/3. That's how you get from shape A to shape B. The length scale factor is the square root of that, which is 2/√3. Okay? And the volume scale factor is the cube of the area scale factor. Well, 2 cubed is 8. √3 cubed is √3 times √3 times √3, which is actually 3√3. Okay? So it's not as straightforward as it might have first seemed. Now, using that information, we're told that the volume of shape B is 10. So we know the volume of shape A is less. So what we're going to do is we're going to divide by this scale factor. Okay, so I'm going to take 10 centimeters and I'm going to divide it by 8/3√3, which is the same as multiplying it by 3√3, okay, over 8. Just turning the fraction upside down. So that calculation will give me the volume of shape A. Now, when you put that into the calculator to 3 significant figures, well, you get 6.495, okay, 6.4951, and it's a decimal that just goes on, but you've got to give it to 3 significant figures, so it's 6.50, okay, centimeters cubed to 3 significant figures. Okay, be careful about rounding that one, because you can't put 6.49, that would be wrong. Okay, so there we are. That's how you answer that question. Okay, in this next question we have also to deal with volumes and areas. So we have 2 cones. I've just made a couple of diagram sketches here just to show what they would look like roughly. This is cone A, okay, and this is cone B. And what we're saying here is that the volume of B is the volume of A to B is in the ratio 27 to 8. So basically, if I took the first cone and went to the second one, the volume would be multiplied by 8/27. Okay, that's the volume scale factor. Okay, so I'm just going to do a little table showing length, area, volume. Okay, and that's going from cone A to cone B. Okay, so the volume is, as we've just shown, 8/27. Okay, now the lengths and heights and distances on cone A and cone B have been affected by a quite different scale factor. In fact, it's the cube root of 8, which is 2, over the cube root of 27, which is 3. Okay, in other words, the height of B is 2/3 of the height of A. The radius of B is 2/3 the radius of A. That's what it means. Okay, now the area scale factor is what lies between, and I get that by squaring the linear one, which is 4 and 9. So the surface area of cone A, if you multiply it by 4/9, you get the surface area of cone B. or any area on cone A, multiply it by 4/9 will give you the same area on cone B. Okay, so what I'm now going to do is use that information about area in here. They're telling me that the surface area of A is 297. So if I take 297 and multiply it by 4/9, which I've just worked out to be the area scale factor, then that should give me 132. And if you check that out on the calculator, that's exactly what it does. So the surface area of cone B is 132 centimeters squared. Okay. This final question is a really unusual question, and the first part's really straightforward. But if you look what you've got to do, you've got to find two possible values of x, and you're told that you've got two triangles that are similar. Okay, so this smaller one and the bigger one are similar. Now I've just redrawn it first of all roughly to scale, okay, because here if that's 12, clearly that isn't 3. Okay, so I've made it look a bit more as if it were to scale by putting the 12 there and the 3 there. Okay, this is the A and this is the D, and there's the point E. Okay, and also I have here the point C at the top. Here's the point B, and there's the 8, and the x is up here. Now you can probably already see that x is going to have to be 2, okay, because you can see that the large triangle has a base of 15, whereas the smaller one has a base of 12, which is 4/5. So the scale factor between the small and the large is 5/4, which means the 8 will become 10. But just to show the working, I would say that x plus 8, that's the total length of the large triangle down the side AC. Okay, if I divide that by 15, I get exactly the same as if I took the smaller triangle, which is just 8/12. Okay, if I multiply both sides by 15, I get x plus 8 equals 15 times 8/12, okay, which is 2/3 of 15, which is 10. So x plus 8 equals 10. Okay, and therefore x equals 2, which is what we said, and we could almost see that was the answer. But there's the working out to justify it. So if that was all the question was asking, you would be finished. And you would have assumed that these two lines here are parallel, which they would have to be to cause the two triangles to be similar. So we think we've answered the question. But of course we haven't, because there's another value of x that we've got to find. And this is really quite difficult to comprehend what's going on here unless you really think deeply about it. So what I'm going to do is take off all this labeling for a minute, okay? And I'm going to take the triangle, the small triangle, okay, outside of the bigger one. And what I'm going to do is look at how else that triangle can be positioned inside this one. And the way I do it is to flip it over. Okay, so this angle stays in this corner, but the 12 goes up to where the 8 is, and the 8 comes down to where the 12 is. Okay, and this is what happens. And I'm going to try and draw it to scale because it's a lot easier to understand. So if I just highlight this triangle first, okay, like that. So that's the shape. I can make a copy of it, which I'll do, and bring it down here. Okay, what I'm now going to do with that copy is I'm going to flip it over. Okay, and I can do that by like that. I'll try and make it about the same size. Just check it's about the same sort of height. Just go a little bit higher. Okay, and then I'm going to rotate it so that the triangle corner is about at the same angle, about there, like that. Maybe a bit more, about there. Okay, so this angle here is now here, but this triangle's been flipped over. Okay, if I can pick that shape up and just pull it a bit out of the way, what I'm going to do now is I've got to make sure that the base of this is the same length, which was 15, because we know that the big triangle is 15 along here. So this bit here is now 8. So I've got to extend it much further. All right, so what I'm going to do is just put that there, move this out the way. Okay, a little bit fiddly this. If I use that space down there, but this time I'm going to take out the rest of this part of the triangle here. Okay, just leaving the smaller triangle, but I'm going to extend those lines so they're roughly in proportion. Okay, so this one has to now be extended so that it's about 7, because remember the total length has to be 15 along there, right? So this bit in here is now 7. You see, sorry, that's 8, and this bit's 7. Okay, and so I also need to extend this one as well correspondingly. Now it's going to go through all this working out, so I'm just going to move that out of the way too. Okay, I don't really need that anymore, but I'll just take it over here somewhere, maybe pop it over there. Right, okay, so let's extend this line right up here now, okay, because the two triangles are still similar, so this line here has to be parallel with this line here. Okay, so if I just make this parallel with this, like that, okay, so I'll just put little arrows on to show that these two are parallel. So that one is parallel with that one, and this line here was originally of length 8 plus x. If I just take that out of the way, okay, that was originally 8 plus x, so it still is 8 plus x, but obviously with a different x. So although this blue line here is 12, we've got to remember that the 8 would stop about there, 4 centimeters away from the end. This length here is now x, okay, and this bit here is still 8. Okay, so if I just put in an arrow to illustrate that more clearly, this bit here and then over to here is x. Okay, so it's quite a difficult problem to fully comprehend what's going on here. Okay, so what we're going to do now is we're going to do the same kind of comparison as before, but this time we're going to say that 8 plus x, okay, which is the length of the long side, okay, or x plus 8, okay, divided by the length of the side opposite here, which is still 15, okay, is equal to, and the new ratio we're dealing with is, instead of 8 over 12, is now 12 over 8. Okay, because I'm now comparing this 12 with this 8 and making the larger triangle similar to that one. So if I multiply that across, I get x plus 8 equals, that'll be 15 times 12 over 8. Okay, and therefore if I just work that out on the calculator, that gives me x equals 15 times 12 over 8, okay, minus 8. Okay, well 15 times 12 over 8 is 1.5 times 15, which is 22.5, and I need to take away from that. That should be minus 8 there. Okay, so it's 22.5 minus 8, which is 14.5 centimeters. And that's the correct answer. A really tricky and unusual sort of problem, that one, but there we go. Okay,